Welcome to our introduction to SDC on RTL, an early timing analysis video. This is Carlos, and in this presentation we will explore the core principles of SDC on RTL and the early timing analysis flow. In today's dynamic FPGA design landscape, where designs continue to grow in size and complexity, timing analysis has emerged as a crucial element of the design cycle. Detecting potential timing issues in the early phases of compilation has become a paramount necessity to increase efficiency and save valuable time. The importance of accurate timing constraints cannot be underestimated. They are the foundation for optimizing results and ensuring that your designs meet the rigorous demands of timing requirements. The Intel Quartus Prime Pro software equips you with capabilities to assign and evaluate constraints early in the compilation flow, specifically during the analysis and elaboration stage. This is made possible through the integration of the early timing analysis flow and SDC-on-RTL support, a feature introduced in version 23.3 and beyond. This innovative approach allows you to seamlessly integrate SDC constraints that target elements within the generated design netlist using the same names as in your RTL design. Thanks to the Intel Quartus Prime Pro software's ability to maintain constraints targets updated, you can consistently apply constraints throughout the entire compilation process with just SDC-on-RTL files, adopting a write-once-use-everywhere approach. This empowers you to iterate more frequently, as you no longer need to rerun the feature every time your design changes. Following the analysis and elaboration stage, you will gain access to numerous checkpoints to examine the optimizations performed by the Intel Quartus Prime Pro software in your design. The RTL Analyzer among them, which presents a suite of powerful tools to validate the precise application of your constraints within the elaborated netlist. This tool includes features such as the Property Viewer, Sweep Hints Viewer, Constraint List, and more. Within this environment, you can simply navigate your design, inspect the properties of various objects, and confirm that your constraints are implemented precisely where they are intended. The RTL Analyzer also serves as a potent tool for pinpointing areas that require additional constraints, ensuring that your design is fully constrained and in alignment with your intended functionality. SDC-on-RTL grants you the freedom to precisely constrain hierarchical pins using the same names defined in your RTL design. Compliant with SDC 2.1 standards, you can apply constraints to clocks, exceptions, groups, and more. This validation process confirms the presence of these elements within the user design netlist and verifies the correct application of constraints early in the design cycle. This flexibility extends to the ability to target pins on cells like registers, employ wildcards to address multiple nodes simultaneously, and efficiently apply constraints to ports of your modules, all within the early stages of the compilation flow. Furthermore, SDC-on-RTL eliminates the need for in-depth knowledge about the origins of signals. Whether you are working with IPs or handling collective designs featuring unknown partitions, you can now apply module ports constraints without having to know specific node names or signal origins. The early timing analysis flow also supports running the timing analyzer directly after synthesis. The post-synthesis timing analyzer loads constraints defined in your SDC-on-RTL files, providing an additional means to validate correct constraint application through the multiple available reports. Additionally, it offers an early glimpse into the core timing of your design during the initial stages of the design cycle. This speeds up the overall design process and allows for early detection of timing closure issues, ultimately accelerating your path to meeting timing requirements. But there's more. You retain the capability to target nodes from the compiler-generated netlist of synthesized nodes to incorporate additional SDC constraints, thereby complementing or overriding constraints defined via SDC-on-RTL files. This further refines your timing analysis, resulting in even more precise results. In conclusion, SDC-on-RTL empowers you to address the design netlist comprehensively by targeting hierarchical pins and module boundaries, even without the need for in-depth knowledge of node names or signal origins. It embraces a write-once-use-everywhere constraint methodology while offering the flexibility to include supplementary synthesis or feeder SDC constraint files, making it suitable for various design scenarios. Combined with tools like the RTL Analyzer and the Post-Synthesis Timing Analyzer, the early timing analysis flow provides an efficient means to validate constraint application within your design and gain early insights into core timing, all using your RTL design within the early stages of your design cycle. Thanks for watching.